Good evening, everyone. For the recent weeks, we learned to solve different cases of first-order differential equations. For this evening, we're going to discuss one of the applications of first-order differential equations. We're going to discuss how to solve growth and decay problems. To understand growth and decay in real-world scenarios, we need to understand first the concept of exponential growth law. The exponential growth law states that the rate of change of a quantity or amount is proportional to the current quantity or amount. Q is used to represent the quantity or amount at a given time t. Q sub 0 is the quantity when t is equal to 0. It is the initial amount. And dq over dt refers to the rate of change of the quantity. Based on the exponential growth law, we can write it as dq over dt is proportional to q. If written mathematically, dq over dt is equal to k times q, where k refers to continuous compound growth rate or the proportionality constant. If we're dealing with growth problems, k is the relative growth rate or kung gaano kabilis lumago yung quantity. If we're dealing with decay problems, k represents the relative decomposition rate or kung gaano kabilis ma-decompose yung isang quantity. This dq over dt equals k times q is an example of mathematical model. Mathematical model refers to the equation that describes physical problems or real-world scenarios in mathematical terms. It is often contains derivatives, and mathematical models with derivatives is a differential equation. Now, we need to solve for the general solution of the mathematical model for the exponential growth law. We can separate the variables in our mathematical model since it is a separable differential equation. First, just multiply dt both sides. And then, divide q both sides. Next, we're going to integrate both sides. The integral of dq over q is ln q. On the right side, we have the integral of k dt. Ilabas lang natin si k kasi constant siya. Integral of dt is t. After simplifying, sa right side we have k times t plus c. Next, simplify by taking the anti-logarithms both sides or i-base e both sides para makancel lang yung ln. So now we have q is equal to e raised to kt times e raised to c. Based sa libro, itong e raised to c is equal to the initial quantity. And q of 0 or the quantity when t is 0 is the same as q sub 0. Palitan lang natin yung e raised to c ng q sub 0. Now, our general solution is q equals q sub 0 times e raised to kt. Explain pa natin kung paano nakuha yung value ng e raised to c. E raised to c is the same as c. If we want to solve for the value of c, we can use the quantity when t is 0. Let q equals q of 0 or q sub 0. Lagay natin sa general solution natin. And remember, yung time natin is 0. K times 0 is 0. E raised to 0 is 1. C times 1 is c. Therefore, q sub 0 is equal to c. Ngayon, itong general solution ng mathematical model natin for exponential growth law or exponential growth equation, magagamit na natin siya for solving growth and decay problems. Mas okay din na memorize natin yung exponential growth law equation. Kasi kung di natin memorize, magsosolve pa ulit tayo ng separable differential equation.
Maraming applications itong exponential growth law, such as real-life problems in population growth, investment and interest, radioactive decay, and etc. Here we have various growth models. we have unlimited growth, exponential decay, limited growth, and logistic growth. Unlimited growth usually occurs sa populations ng mga organisms, particularly if their habitat has unlimited resources. Yung exponential decay model naman, dito it represents the certain quantity decreases at a rate proportional to the amount left. Yung limited growth naman, it refers to the exponential growth that will eventually cease to increase. Lastly, we have logistic growth. In this model, at a certain point, the relative growth rate of a population will eventually decreases because of limited resources. Kung titignan natin yung model ng logistic growth, half of the time, the graph looks like graph of unlimited growth, but at a certain point of time, the graph will look like the graph of limited growth.
Sa mga ganitong word problem, kailangan talaga natin i-analyze ng mabuti. Kagaya ng sa example 3.1. Ang sabi dito, the substance decompose at the rate proportional to the quantity of substance present. If the half-life of the substance is 1,000 years, find the percentage that remains after 250 years. Mag-focus muna tayo sa if a half-life of the substance is 1,000 years. Meaning, na after 1,000 years, ang natirang substance ay kalahati na lang. I-analyze naman natin ang given. First is the time. And the value for time is t equals 1,000 years. Given din ang quantity. And sabi nga dito, after 1,000 years, kalahati na lang ang natira. Meaning, kalahati ng initial quantity. Kaya ang quantity dito ay equal sa 1/2 ng initial quantity or 0.5 q sub 0. Gagamitin nating formula ay exponential growth law, which is q equal q sub 0 multiplied by e raised to kt. Kung mapapansin nyo, may value na tayo ng q and t. Ang wala na lang ay q sub 0 or yung initial quantity and yung e raised to k. Sa initial quantity, wala na tayong problema dyan dahil percentage ang kukunin natin mamaya. Kaya magpo-focus tayo sa pagkuha ng value ni e raised to k. Alam naman natin ang value ni q and t, kaya papalitan na natin ang value nila. 0.5 q sub 0 equal q sub 0 multiplied by e raised to k times 1,000. Kung mapapansin nyo, may pwede tayong i-cancel which is q sub 0. Kaya i-divide natin both side ng q sub 0. Ang matitira na lang ay 0.5 equal e raised to k times 1,000. Ngayon, ang gusto na lang natin matira sa right side ay e raised to k. Kaya i-raise natin both sides sa 1 over 1,000. Then 1,000 multiplied by 1 over 1,000 is 1. Kaya k na lang ang matitirang exponent ni e. Sa left side naman, ganun din. I-raise natin sa 1 over 1,000. So 0.5 raised 1 over 1,000 is equal to e raised to k. So ayun, may value na tayo ng e raised to k or compound growth rate. Balik tayo sa pinaka-problem, which is ilang percent ang matitira sa initial substance after 250 years. Dito, ang hinahanap ay quantity or q. Pero wala tayong exact value ng initial quantity. Pero malinaw naman na percentage ang hinahanap. Kaya okay lang kahit wala tayong exact value ng q sub 0. So ang given ay time, which is t equal 250 years, and kanina na-compute na natin ang value ni e raised to k, which is 0.5 raised to 1 over 1,000. Then plug in na natin sa formula ng exponential growth law. Q equal q sub 0 multiplied by 0.5 raised to 1 over 1,000 times 250. Pag minultiply natin ang 1 over 1,000 at 250, ang magiging answer nan ay 250 over 1,000 or 1/4 pag ni-lowest term. So ayun, pwede natin i-input sa calcu ang 0.5 raised to 1/4 para makuha ang percentage kung ilan na lang ang natira sa initial quantity ng substance, and ang lumabas na value is 0.840896 or 0.8409 pag ni-round off. Kaya ang answer is Q equal 0.8409 Q sub 0, which is pag nilagyan natin ng value ang Q sub 0, ang magiging sagot nun ay 84.09% nito ang matitira after 250 years. Ang final answer is 84.09%.
Example 3.2. An Asian country had a population of about 0.9 billion people in 1995 and a growth rate of 1.3% per year, which is assumed to be compounded continuously. In what year, approximately, will its population be at 1.5 billion? So basically, we're looking for what year does the population will be at 1.5 billion. In the given problem, we only have the growth rate, the year, and the initial population. It is stated that in year 1995, the total population was 0.9 billion. The growth rate is 1.3% per year. And in what year it become 1.5 billion? Now we're looking for what year or the time. Our equation will be population is equals to P sub 0 or the initial population multiplied by E raised to K times time. Our K will be 0.013 or the growth rate of 1.3%. The initial population or the P sub 0 is 0.9 billion. The population is 1.5 billion and the time or the T is the missing one. So let's insert the given in the equation, which will be having 1.5 equals to 0.9 multiplied by E raised to 0.013 multiplied by T. We need to get the time or T, so let's divide both sides by 0.9 to cancel out the 0.9 on the right side. So our equation now is 1.5 over 0.9 is equals to E raised to 0.013 multiplied by T. And next step is get the antilogarithms of both sides or the ln both sides. And we will be having ln 1.5 over 0.9 is equals to ln E raised to 0.013 multiplied by T. We all know that ln E is equals to 1, so let's just cancel out and we will be having ln 1.5 over 0.9 is equals to 0.013 multiplied by T. Next step is divide both sides by 0.013 and we will be having 1 over 0.013 ln 1.5 over 0.9 is equals to T. Solving using the calculator and T will be and the answer for the T is 39 years. Our initial year is 1995 plus 39 is equals to 2034. So in year 2034, the total population was 1.5 billion with a growth rate of 1.3%.
So now let us proceed to example number 3.3. A depositor currently has 10,000 pesos and plans to invest it in an account accruing interest continuously at 12% per year. How long will it take for the investment to grow 25,000 pesos? So ang mga given na meron tayo for this example ay ang Q sub 0, which is 10,000 pesos, invested at an interest rate or K, which is equals to 12% or 0.12, at present din ang Q, which is equals to 25,000 pesos. At ang hinahanap natin sa problem na to ay ang time or T. To solve this, ang gagamitin pa rin nating formula ay Q is equals to Q sub 0, E raised to K multiplied by T. I-substitute na natin ang mga given. So, meron tayong 25,000 is equals to 10,000 E raised to 0.12 multiplied by T. And divide natin both sides sa 10,000. So, makakancel ang 10,000 over 10,000 sa ating right side at matitira ang E raised to 0.12 multiplied by T. And mayroon naman tayong 25,000 over 10,000 sa ating left side. Para makancel ang E, get the ln of both sides. And now, we have ln of 25,000 over 10,000 is equals to 0.12 multiplied by T. Since wala na ang e, pwede na nating multiply both sides sa 1 over 0.12. So, cancelled na ang 0.12 sa ating right side at matitira ang t. While on the left side, the ln of 25,000 over 10,000 multiplied by 1 over 0.12 is equals to 7.64. So our final answer here is 7.64. Therefore, the investment will grow from 10,000 to 25,000 in 7.64 years, or approximately 7 years and 8 months.
Now, let's proceed to logistic differential equation. A logistic differential equation is a mathematical model used to describe the real population growth with a constraint carrying capacity from a certain environment. As population size approaches carrying capacity, the growth rate gets smaller. Otherwise, the growth rate increases exponentially. In other words, population size is inversely proportional to carrying capacity. As mentioned earlier, the formula for exponential growth is dp over dt is equal to kp. But in logistic differential equation, we need to insert a limiting factor, which is the population deviation, by multiplying 1 minus p over m in the right side of the exponential growth formula, where p is population and m is the carrying capacity. But in the book, carrying capacity is denoted as capital letter K. I choose M because small letter k represents the growth rate. Moving on, let's derive the logistic growth formula from dp over dt is equal to kp times 1 minus p over m. First, multiply dt both sides or simply cross multiply. The result is dp is equal to kp times 1 minus p over m dt. Then we separate variables of p and t. We divide both sides by p times 1 minus p over m. Please note that we are keeping the growth rate k on the right side because it is not a p. So we will get 1 all over p times 1 minus p over m dp is equal to k dt. Next, compute for the LCD of 1 and p over m, which is m. Then rewrite those terms in terms of m by dividing the denominator of each term to its LCD and multiplying it to numerator. We will get 1 all over p times m minus p over m dp is equal to k dt. Next, simplify 1 over p times m minus p over m dp by obtaining the reciprocal. So we will get m over p times m minus p dp is equal to k dt. At this point, we can proceed to integration. Notice that the left side of the equation can be decomposed into partial fractions. So we will have the integral of a over p plus b over m minus p is equal to integral of k dt. Instead of using the usual method in partial fractions, I have researched another way called the cover-up method by black pen, red pen. Links of the said method are provided in the comment section of Google Meet. First, analyze the degree of denominators of p and m minus p. Notice that both of them are in the first degree, meaning a and b must be both constants. Next, proceed to get the value of a in a over p. Rewrite the original m over p times m minus p. Equate the denominator of a over p to 0, and the value of p is 0. Next, we literally cover or erase p from p times m minus p and substitute the value of p inside m minus p. So we will get m over m minus 0. Then simplify. We have m over m is equal to 1, which is the value of a. With the same process, let's obtain the value of b. Again, rewrite the original m over p times m minus p. Equate the denominator of b over m minus p to 0. Transpose p to the right side, which will give m is equal to p, or by symmetric property of equality, p is equal to m. Next, we cover or delete m minus p from p times m minus p. So we will get m over p. Then substitute the value of p. We will have m over m is equal to 1, which is the value of b. Substitute the value of a and b. We will get the quantity of integral of 1 over p plus integral of 1 over m minus p dp is equal to integral of k dt. Now, we can integrate both sides with respect to p on the left side and t on the right side. It will give us ln of p minus ln of m minus p is equal to kt plus c. We can apply the subtraction property of natural logarithm in the left side of the equation. We'll get ln of p over m minus p is equal to kt plus c. To eliminate natural logarithms, we base e both sides. We will get the absolute value of p over m minus p is equal to e raised to kt times e raised to c. Next, simplify e raised to c, which is still a constant c, by eliminating the absolute value in the left side, which will give p over m minus p is equal to plus minus c e raised to kt. Next, plus minus c is still a constant c, and simultaneously get the reciprocal both sides, which will give m minus p over p is equal to 1 over c times e raised to kt. Let's raise c times e raised to kt to the numerator side, which will transmute to m minus p over p is equal to c raised to e negative kt. Multiply both sides by p or simply cross multiply. The result is m minus p is equal to p times c raised to e times negative kt. Transpose negative p to the right side. We will get m is equal to p times c e raised to negative kt plus p. Factor out p from p times c times e raised to negative kt plus p. We will obtain m is equal to p times c raised to e negative kt plus 1. Divide both sides by c times e raised to negative kt plus 1. And by symmetric property, p is equal to m over c times e raised to negative kt plus 1. And we put time, denoted as t, in the population size, which will give p of t is equal to m over c times e raised to negative kt plus 1. This is the formula for logistic growth. To find the value of c, we set the value of t to 0. By substitution, p of 0 is equal to m over ce raised to k times 0 plus 1. Anything raised to 0 is equal to 1. And remember, p of 0 is denoted as the initial population. So, p of 0 is equal to m over c plus 1. Next, reciprocal both sides to gain more numerator terms on the right side of this equation. We will obtain 1 over p of 0 is equal to c plus 1 over m. Simply cross multiply, which will give m over p of 0 is equal to c plus 1. Transpose 1 to the other side, and at the same time, do the symmetric property of equality. We will get c is equal to m over p of 0 minus 1. Next, we get the LCD of p of 0 and 1, which is cp of 0, and rewrite it in terms of its LCD. We will get c is equal to m minus p of 0 over p of 0. Finally, we replace the value of c from p of t is equal to m over c times e raised to negative kt plus 1. We will obtain the formula for logistic growth. Let's try to apply this derived formula to a sample problem. Mark, a biologist, is studying a colony of bacteria in a controlled environment. At the beginning of his observation, the colony consists of 100 individuals, and he knows that the environment can sustain a maximum of 1,000 individuals. The bacteria population growth is at a rate of 0.2 per hour. How many bacteria does Mark predict will be in the colony after 5 hours? First, let's state the given. The initial population is 100. The carrying capacity denoted by m is 1,000. The growth rate is 2 and the time is 5. Next, the formula to be used is growth, logistic growth, which is p of t is equal to m over m minus p of 0 over p of 0 times e raised to negative kt. Then, we substitute the given values. P of 5 is equal to 1000 over 1000 minus 100 over 100 times e raised to negative 2 times 5. Simplify 100, 1000 minus 100 over 100 and e raised to negative 0.2 times 5. We will get P of 5 is equal to 1000 over 9 times e raised to negative 1. Finally, input this in the calculator and we will obtain 232.138572488. We generally round down this value, but we need to round up to 233 since we are talking about the life of an organism or an individual. We can never go under the value that we get in this case.
So let us proceed to problem set number 1. Suppose that you find in your parents' room a library book on which your father owed a 10 pesos overdue fine 30 years ago. Suppose that a fine grows exponentially at 3% annual rate compounded continuously. How much would your father have to pay if he returned it today? So first, let's list down all the given in this problem. We have Q sub 0, which is 10 pesos, and T for time is equals to 30 years, and also the K or relative growth rate is 3% or 0.03. In this problem, the missing is Q. So para mahanap natin si Q, ang gagamitin nating formula ay Q is equals to Q sub 0 e raised to KT. So i-substitute na natin ang given. Magiging Q is equals to 10 e raised to 0.03 multiplied by 30. To solve this, the answer is 24.596 or 24.60 pesos kung ni-round off. Therefore, my father will pay 24.60 pesos if he returned the library book today.
Example number 3. If initially 500 mg of a material is present and after 3 years 20% of the original mass has decayed, determine the amount remaining after 25 years. In this problem, we're looking for the amount remaining after 25 years. In the given problem, we only have the initial quantity, or the Q sub 0, the time, or the T, and the quantity, or the Q. And we're missing for the K. We have to look for the value of K first in order for us to get the amount remaining after 25 years. Our equation that we will be using is Q equals to Q sub 0 multiplied by E raised to KT. So let's list down our given. The Q sub 0 is equals to 500. The T is equals to 3 years. And for the quantity is 500 minus 500 multiplied by 20% is equals to 400. Which is the 500 is our initial quantity and the 20% is a decayed quantity after 3 years. So the 20% of 500 is equals to 100. So 500 minus 100 is equals to 400. So our quantity is equals to 400. So let's insert the given in the equation. We will be having 400 is equals to 500 multiplied by E raised to K3. And divide both sides by 500. And it will be 400 over 500 equals to E raised to K3. After that, let's get the anti-logarithm or the ln both sides. And we will be having ln of 400 over 500 is equals to ln E raised to K3. ln E is equals to 1. Let's cancel that out. And we will be having ln 400 over 500 equals to K3. Next step is divide both sides by 3. So 1/3 ln 400 over 500 equals to K. So that's the value of our K. Let's get the quantity remaining after 25 years. Our equation will be the same. Q is equals to Q sub 0 multiplied by E raised to K3, KT. But our Q will be Q sub 25 since we're looking for the amount after 25 years. So Q sub 25 is equals to 500 multiplied by E raised to 1/3 ln 400 over 500 multiplied by 25 or the 25 years. Let's solve this in the calculator and we will be having is 77.87 milligrams. So after 25 years, the material remaining will be at 77.87 milligram.
Now, let's solve number 5. A culture of bacteria grows at a rate that is proportional to the present number. It is found that the number of bacteria doubles every 4 hours. If there are 10 raised to the 4th power bacteria at the end of 3 hours, how many were there at the start? Bale, ang pinapahanap dito is yung initial quantity. Bago natin hanapin yung pinaka-value ng initial quantity, analyze muna natin yung mga mas naunang given. Hindi given si K o yung relative growth rate. Sinabi lang na yung mismong population ng bacteria or yung quantity is nadodoble kada 4 hours. Since walang ibang quantity na binigay sa naunang given, let's use Q sub 0 as the base of our population. Let Q equals Q of 4, where Q of 4 is the quantity when T is equal to 4. And alam natin na kada 4 hours, nadodoble yung population. Kaya Q of 4 is equal to twice the Q sub 0. Let's use these values and substitute natin sa exponential growth law equation natin para mahanap natin si K. Q is equal to Q sub 0 times E raised to KT. Palitan natin si Q ng 2Q sub 0. Si Q sub 0 naman sa right side, hindi na natin siya gagalawin. Since hindi naman given si Q sub 0, actually isa rin siya sa hinahanap, stay lang siya dyan. Tapos, yung T natin is 4. Ngayon, divide both sides by Q sub 0 para makancel yung Q sub 0. Ang matitira is 2 equals E raised to 4K. Simplify by taking the anti-logarithms both sides or by simply getting the ln both sides. Bali magiging ln2 sa left side and yung ln e sa right side is maka-cancel. Ang matitira na lang ay 4K. Para makuha na natin si K, divide both sides by 4. Finally, the value of K is equal to 1/4 times ln2 or ln2 over 4. As much as possible, para mas accurate yung computation natin, hindi na muna natin gagawing decimal yung K natin. Bali buong 1/4 ln2 or buong ln2 over 4 yung gagamitin natin. After solving our relative growth rate or the K, hahanapin na natin si initial quantity, knowing that there are 10 raised to the 4th power amount of bacteria after 3 hours. And 10 raised to 4 is the same as 10,000. Recall lang natin ulit yung general formula for our growth problems. Q is equal to Q sub 0 times E raised to KT. Since meron daw 10,000 bacteria after 3 hours, so we're going to let Q equals 10,000 and T equals 3. Substitute lang natin yung mga values ni Q, T, and K sa equation natin. So now we have 10,000 is equal to Q sub 0 times E raised to ln2 over 4 times 3. ln2 over 4 is the same as 1/4 ln2. And we can multiply 1/4 and 3, so magiging 3 over 4. Using the exponent property ng logarithms, yung 3/4 pwedeng iakyat at magiging exponent ni 2. So magiging E raised to ln of 2 raised to 3/4. Tapos, maka-cancel yung E tsaka ln kasi another law of a logarithm or another property ng logarithm. Kaya ang matitira na lang is 2 raised to 3/4. Divide both sides by 2 raised to 3/4. So now we have Q sub 0 or the initial quantity equals 10,000 divided by 2 raised to 3/4. Let's use our calculator para ma-solve ito. So, Q sub 0 is equal to 5,946.035575 or approximately 5,946.04 if we're going to consider 2 decimal places, or pwedeng approximately 5,946. Ngayon, if i-check natin yung nasa choices, walang 5,946. Pero ang pinakamalapit na sagot is 5,947, which is isa lang ang pagitan. So we assume na nag-round up ng sagot. Para ma-verify yung sagot, let's both use 5,946 and 5,947 as our initial quantity. And dapat 10,000 or approximately 10,000 ang lalabas sa sagot. Gamitin ulit natin yung formula. Q is equal to Q sub 0 times E raised to KT. Unahin na muna natin si 5,946 as the initial quantity. Q is equal to 5,946 times E raised to ln 2 over 4 times 3. Let's use our calculator again. Ang magiging sagot is 9,999.94017. Pag ni-round up to the nearest whole number, magiging 10,000. Next is yung 5,947 as our initial quantity. So now we have Q is equal to 5,947 times E raised to ln 2 over 4 or 1/4 ln 2 times 3. Gamit ng calculator, ang lalabas is 10,001.62196 or approximately 10,002. Kung papansinin natin, mas malapit sa 10,000 yung magiging sagot kung ang initial quantity natin na gagamitin is 5,946. Kung i-compare natin yung 5,946 and 5,947, mas accurate na sagot yung 5,946. Kasi mas malapit sa 10,000 yung Q pag si 5,946 yung initial quantity.
Let's proceed to the next question. The number of bacteria in a certain culture increased tenfold in 3 hours. How long did it take for the population to triple? Focus muna tayo sa unang statement. Sabi dito na ang bacteria ay nag-10 times after 3 hours. Therefore, ang time natin is equal to T equal 3 hours. And yung value ng Q natin ay 10 times ng initial quantity. Kaya Q is equal to 10 Q sub 0. Gagamitin natin ang formula na exponential growth rate, which is Q equal Q sub 0 multiplied by E raised to KT. Kung mapapansin nyo, may value na tayo ng Q, which is 10 Q sub 0. Eh yung T natin is equal to 3. Kaya i-plug in na natin ito sa ating formula. So 10 Q sub 0 equal Q sub 0 multiplied by E raised to K times 3. Kung mapapansin nyo, wala tayong value ng initial quantity or Q sub 0, which is hindi magiging problema dahil makakancel din yan later on. Mag-focus tayo sa value ni K or yung continuous growth rate. Mismong value ni K ang kukunin natin, hindi E raised to K dahil mas malilito tayo doon. Sa pagkuha ng value ni K, divide muna natin both side sa Q sub 0, kaya makakancel na natin ang Q sub 0 both side. Magiging 10 equal E raised to K times 3. Ngayon naman, kailangan natin kunin ang ln ng both side para makancel natin si E. Kaya magiging ln 10 equal K times 3. Last step, kailangan natin tanggalin ang 3 sa tabi ng K. Pwede natin gawin ay i-multiply natin both side ng 1/3 para matira na lang sa K sa right side. Magiging 1/3 ln 10 equal K. So may value na tayo ng K or continuous growth rate, which is 1/3 ln 10. Ngayon, mag-focus na tayo sa main problem na how long did it take for the population to triple. Kung kanina 3 hours bago maging tenfold ng bacteria, ngayon hahanapin natin kung ilang oras bago maging threefold or maging 3 times ang ating bacteria. Isa-isahin natin ang given and ang hinahanap. Given ang Q, which is 3 times ng initial quantity. So Q equal 3 Q sub 0. And ang time natin ay unknown. Ang gagamitin nating formula is exponential growth law, which is Q equal Q sub 0, multiplied by e raised to kt. Nahanap na natin kanina ang k sa problem na ito, which is k equal 1/3 ln 10. Then plug in na lang natin ito pati na rin yung value ni q. So 3q sub 0 equal q sub 0 multiplied by e raised to 1/3 ln 10 times t. First, divide natin both side by q sub 0 para makancel natin ito both side. Kaya magiging 3 equal e raised to 1/3 ln 10 times t. Ngayon, para makancel ang e, kunin natin ang ln ng both side. Kaya magiging ln 3 equal 1/3 ln 10 times t. Ang last step para makuha natin ang value ni t or time, kailangan natin i-divide both side ng 1/3 ln 10 para makancel natin ang kasama ni t sa right side. Magiging t equal ln 3 over 1/3 ln 10. Pwede na natin ito i-input sa ating calculator para makuha natin mismo ang value ni t. Pag in-input natin yan sa calculator, ang magiging answer ay 1.4313 or 1.43 pag ni-round off.
Problem number 9. The population of the US in 1800s was 5.3 million people, and in 1850 was 23.1 million people. Predict its population in 1950 using the exponential model of growth. In this problem, we need to find the value of growth rate denoted as k in order to predict population in any time or year. First, let's jot down the given. We set the initial population is 5.3 million in 1800, 23.1 million as population at a given time denoted as p, which is in 1850, and time denoted as t is 50, because the difference between 1850 and 1800 is 50. Next, we use the exponential growth formula, which is p is equal to p of 0 times e raised to kt. Let's plug in these values. 23.1 is equal to 5.3 times e raised to k times 50. Divide both sides by 5.3 so we can isolate the k. That will give us 23.1 over 5.3 is equal to e raised to 50k. Let's take the natural logarithm both sides so we can eliminate the e. Then multiply both sides by 1 over 50. And by symmetric property of equality, k is equal to 1 over 50 times ln of 23.1 over 5.3. We don't need to simplify the natural logarithm so we can get a more accurate value for the missing value. Now that we have the value of growth rate, we can predict the population for 1950. Again, use the formula for exponential growth. That will give us p of 150 is equal to 5.3 raised to 1 over 50 times ln of 23.1 over 5.3 times 150. We multiply the exponent 1 over 50 and 150 so we can simplify it a little before plugging it in the calculator. That will give us p of 150 is equal to 438.8177643. In the choices, all of them are rounded to the nearest tenth. So our answer will be 438.8 million, which is letter D in the choices.